If you rearrange, their order will also change. So therefore here we have 4 letters. In that E is repeating 2 times. If one number is filled, you cannot repeat it on the second place. There is no repetition of letter E in the 9 letters remaining. So therefore it is 9 factorial by 3 factorial, 2 factorial into 2 factorial. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysore. So here we are at the revision session of the chapter Permutations and Combination. So in this session, we will be discussing 1 mark, 2 mark, 3 marks question, which is carried out from this chapter. So let's see the distribution of marks from this chapter. So from the chapter Permutations and Combination, you will be having 1 1-mark question, 1 2-mark question and 1 3-mark question, total 6 marks from this chapter. So let us discuss what are the questions you may expect from the examination point of view. So here we have taken previous year question to solve it. Now let's see it. So 1-mark question. In how many ways can 10 people be seated around a table? So we have 2 types of permutation. One is linear permutation, another one is circular permutation. Around a table is nothing but it's a circular permutation, that is arrangement of any objects, people, certain things, etc. So if it is a linear permutation, arrangement of n object, in case of linear permutation we take it as n factorial, but in case of circular permutation we always take the arrangement as n minus 1 factorial. So therefore here we have 10 people around the table, hence the number of arrangement is 10 minus 1 factorial, that is 9 factorial. So this question was asked in March 2015, 2017 and 2019. Next. Find n if NC8 is equal to NC7. So this is one of the important property of the combination, that is if 2 combinations are equal, then it is nothing but A is equal to B or A plus B is equal to N. Here A and B are not equal, so therefore N is A plus B. So therefore what is the value of N? We can say N is equal to 8 plus 7, that is equal to 15. Next. How many different arrangements can be made with the letters of the word Monday? So we have 6 different letters. No letter is repeated. So arrangement of 6 letters is nothing but arrangement of 6 objects. Arrangements, it's a linear permutation. So therefore we can write answer as 6 factorial. So next question, how many straight lines can be formed from 10 points if no 3 of them are collinear? So they are not collinear means they are not on the same straight line. So therefore we have 10 different points at 10 different positions. So therefore how many lines we can draw is for draw a line you need 2 points, but here we have 10. So therefore we can select any 2 points to draw a line. So therefore it is 10C2. So the number of straight lines that you can draw where all of them are collinear is 10C2. So the next one, if NP3 is equal to 210, find N. So here NP3 can be written as N factorial by N minus 3 factorial. N factorial can be written as N into N minus 1, N minus 2, N minus 3 factorial. So N minus 3 factorial is equal to 210. We can cancel. So we get N into N minus 1 into N minus 2 is equal to 210. So you can verify this by the method of inspection. So by inspection, so if you divide 210 by number 7, 3, 6 into 5. So you can guess it is in the form of 7 into 6 into 5. So what must be the value of N? So N must be 7. By inspection we can call N is equal to 7. That is 7 into 7 minus 1 into 7 minus 2 is equal to 210. That is 7 into 6 into 5 is equal to 210. So we can take the value of N as 7. Next. How many 4-digit number can be formed using the digits 1, 2, 4, 5, 7, 8, 9, no digit being repeated. So how many digits we have? 1, 2, 3, 4, 5, 6, 7. So 7 digit we have, and out of that we need to take only 4 digits. So the value will be 7p4, that is 7 factorial by 7 minus 4 factorial, that is 3 factorial. So the value is 7 into 6 into 5 into 4. So or you can use the method of the columns. So 4 digit number means you have ones place, tens place, hundreds place and thousand place. So you have total 7 digits. Suppose if you have all the chances to fill in the 1000 place, that is all 7 chances. If one number is filled, you cannot repeat it on the second place. So therefore, here it reduces. Similarly, it goes like this, 7 into 6 into 5 into 4. So the total number of 4 digit number that can be formed is 7 into 6 into 5 into 4. Hence, the value is equal to 280. So like this, they may ask you very simple questions to solve under circular permutation or linear permutation, etc. So next question we have, in how many ways can 3 boys and 4 girls be arranged in a row so that all 3 boys sit together? So here 3 boys, 3 girls means 1, 2, 3 and 4 girls 1, 2, 3, 4. So here they have given all the 3 boys must sit together. So let me take this as 1 unit. So other 4 places as 4. So to total we have 5 units. So therefore the number of arrangements is equal to 5 factorial. But the 3 places of boys can also be interchanged, and hence we have 3 members, they can interchange their places. So therefore they have 3 factorial ways to arrange themselves. So therefore it is equal to into 3 factorial. 5 factorial is for the placement for girls as well as the 3 boys. So considering this as 1 unit, because they cannot be separated, they always sit together. So interchanging their place in one position, we will get 5 factorial. And the 3 boys can also exchange their places in however way they want, because they all sit together. Their place may also be interchanged. Hence we have 3 factorial. So therefore the total number of arrangements is here 5 factorial into 3 factorial. Next, find the number of parallelogram that can be formed from a set of 6 parallel lines intersecting another set of 4 parallel lines. So we have a formula, that is number of parallelograms is 6C2 into 4C2. So that is equal to 6 into 5 divided by 2 into 4 into 3 divided by 2. So 2 cancels, 2 3 cancels. We have 15 into 6, that is equal to 90. So we can form 90 parallelograms from the set of 6 parallel lines intersecting the set of 4 parallel lines. So next question, in how many ways can 6 gentlemen and 4 ladies be seated around a table so that no 2 ladies are together? So we have 6 gentlemen around a table, 1, 2, 3, 4, 5, 6. So they are sitting around the table. So therefore, number of arrangements of gentlemen will be 5 factorial, because it is always 6 minus 1 factorial for a circular permutation. Now we have 4 ladies being seated around a table so that no 2 ladies sit together. That means we have to fill in between. So how many places we have for ladies? Again we have 6 places. So from that 6 places, they have to select only 4 places to be seated. So therefore the combinations will be 6p4. So this is the number of arrangements. Since they are sitting around a table, 6 gentlemen can arrange themselves in 5 factorial ways, and we have 6 remaining places between the gentlemen, but we can fill only 4 ladies. So therefore out of 6 places we can fill only 4. So therefore we have 5 factorial into 6p4 ways of arrangements. So the next question is, in how many ways can 6 people be selected out of 12 people so that 2 particular members are always included? So that means 6 peoples, we have to include 2 people, that is from the 12 people. That means out of 12, we have to include 2. So therefore the selection must be made only with the 10 peoples, and out of 6 peoples, we have to include those two. So therefore, the selection is only for 4. So therefore, total particular members must be included. So the number of ways for the first one is 10C4 only. Because we have already included 2 people, we need only for the selection for 4 people. Next, for the second one, 2 particular members must be excluded. That means out of 12, we need to exclude. So the remaining is only 10. And from the 10 members, we have to select 6 people. So therefore, the number of ways is 10C6. So next question, in how many ways the word carom be arranged such that 2 R's are always together? So carom means C-A-R-R-O-M. So these 2 letters must be single unit. So let me take, and along with that we have here 2 places, here 2 places. So total we can arrange them in 5 factorial ways. But if you interchange an RR position, it doesn't change the order. So it is one and the same. So therefore here the number of ways is 5 factorial only. If you have different letters like R and S, and if you interchange, it will become S and R. So therefore, you have to multiply into 2 factorial there. But here it is not necessary because they are one and the same. If you change their order, it will not give another arrangement. So therefore, when 2 are taken as 1 unit, considering other 4 units, total you have 5 units. So therefore, you can arrange them in 5 factorial ways. So next one is 3 marks question. So in 3 marks question, you will be having questions like number of arrangement of letters from a particular word. So here we have an example. Find the number of permutations of the letters of the word engineering. How many of these begin with green, have all 3 E's together, begin with E, end with E? So first let us find the number of permutations of the letters of the word engineering. So we have the letter engineering. Here we have E 1, 2, 3 times, and N 3 times, G 2 times, I 2 times. So now what is the total number of permutations? So total ways will be, so how many letters we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So therefore it will be 11 factorial. Since there is a repetition of letters, we have to divide it by the repetition number. So 3 factorial, 3 factorial, 2 factorial, 2 factorial. So this is the total number of ways. Now coming to the sub question, here the word must begin with green. So if you remove this green, because they are not in the number of arrangements now, they are not considered under selection. So how many letters are remaining? If you leave green, they are not under consideration. So you have remaining 7 factorial. Now therefore, the total ways here is 7 factorial. But under 7 factorial also, you have a repetition of digit. So G is repeated 2 times, which is not taken as consider, because 1 G is here, 1 G is here, so we can't write. Next we have R, which is not necessary. I we have 2 times, which is not necessary. If it is I here, then it is I here also. Next we have E and N repeating here with the 7 factorial. So we have to divide it by 3 factorial, 3 factorial. So therefore for the sub question 1, the answer is 7 factorial divided by 3 factorial, 3 factorial. Next we have all 3 is together. So that means we have all 3 is together. So if all the 3 is are together, then here we are left with 8 letters. So here we have total 8 letters. We should consider this as 1 unit. So the number of permutation will be 9 factorial. Except G, we have a repetition of N, so divided by 3 factorial, G also 2 factorial, and I also 2 factorial. Here we can multiply the arrangement of E, but since they are one and the same, if you arrange them, their order will not change. So therefore it is not necessary to write. So for the sub question 2, it is 9 factorial by 3 factorial, 2 factorial, 2 factorial. Next we have begin with E and end with E. So if you begin with E and end with E, you should not consider these two E under consideration. So out of 11 letters, 2 letters are already fixed in their places. We have to arrange only 9 letters. So it is 9 factorial divided by N is repeated 3 times, G is repeated 2 times, I is repeated 2 times. And E is repeated 3 times, but the places of 2 E's are already fixed, so they'll not come into the arrangement, and 1 E is remaining. So there is no repetition of letter E in the 9 letters remaining. So therefore it is 9 factorial by 3 factorial, 2 factorial into 2 factorial. Next, find the number of permutations of the letters of the word committee. How many of these have all vowels together, begin with T and end with T? So how many letters we have? So we have total 9 letters. So therefore total ways will be 9 factorial. But under 9 factorial, we have M repeating 2 times, T repeating 2 times, E repeating 2 times. So this is the total number of ways. Now for the first question, having all the vowels together means, so what are the vowels? We have O, I, E, E. So tie them as one unit. If you tie them as one unit, so from the 9 letters, we have remaining 5 letters. So therefore, total ways becomes, total ways is equal to 6 factorial, because it is 5 plus 1, 6 factorial. Under the remaining letters, 5, what are the remaining letters? Here we have C, M, T, T. So from these remaining letters, we have M repeating 2 times and T repeating 2 times. Now coming to this unit, if you rearrange, their order will also change. So therefore here we have 4 letters, in that E is repeating 2 times. So this is the total number of ways for all the vowels together. Next we have question B, begin with the T, end with the T. So fix the places of T, starting and end. We cannot take them in consider. So leaving 2 T's, we have 7 letters remaining. So from the 7 letters, the total ways becomes 7 factorial. In that 7 letters, we have M repeating 2 times, E repeating 2 times. So therefore it is 2 factorial by 2 factorial. So this is the total number of ways for the letters beginning with T and ending with T. So next we have a question. A team of 11 is to be chosen from 18 cricketers, of whom 6 are bowlers and 3 are wicket keepers. In how many ways can a team be chosen so that there are exactly 4 bowlers and 1 wicket keeper, there are at least 4 bowlers and at least 2 wicket keepers? So let us write this. Total we have 18 cricketers. We have to form a cricket team of 11. So in that 18 cricketers, 6 are bowlers, 3 are wicket keepers, and others 9 members. They are batsmen or something. Now we need to plan to form a cricket of 11. The first question says there are exactly 4 bowlers. From the 6 bowlers, we need to choose 4 bowlers and 1 wicket keeper. That is, 1 wicket keeper means we have 1. So 4 plus 1, 5, and remaining must be here. So therefore, number of ways here will be 6C4 into 3C1 into 9C6. So now the value will be equal to 15 into 3 into 84. So the total ways will be 3780. Next, they have asked you there must be at least 4 bowlers and at least 2 wicket keepers. So for the second one, let's write we have 6 bowlers, 3 wicket keepers and 9 others. So from that, we need at least 4 bowlers and 2 wicket keepers. At least 4 bowlers means we can have 4 bowlers, at least 2 wicket keepers means minimum 2. 4 bowlers or 3. Or I have 5 bowlers, 2 wicket keeper, 5 bowlers, 3 wicket keeper. Or 6 bowlers, 2 wicket keeper, 6 bowlers, 3 wicket keeper. And the 9 remaining will have total 11. So 4 plus 2 is 6. So 6, here we need to take 5. 7, this is 4. Next 5 plus 2, 7. So this is 4. 5 plus 3, 8. You have 3 options. 6 plus 2, 8. You have 3 options. 6 plus 3, 9. You have 2 options. So the formula will be like this for this. So this is 6C4 into 3C2 into 9C5. So for this we have 6C4 into 3C3 into 9C4. Next for the third case we have 6C5 into 3C2 into 9C4. For the fourth case we have 6C5 into 3C3 into 9C3. For the sixth case we have 6C6 into 3C2 into 9C3. For the seventh case we have 6C6 into 3C3 into 9C2. So calculating this, the total will be the number of selections we can make. So for the first one, after evaluating, we have 5,670. For the second one, we have 1,890. Next, for 6C5 into 3C2 into 9C4, we have 2,268. Next, for 6C5, 3C3 and 9C3, we have 504. Next, 6C6, 3C2, 9C3, we have 252. And 6C6, 3C3, 9C2, we have 36. So by adding all the things, we have total 10,620 ways of selecting the cricket players. Next, if a convex polygon has its 170 diagonals, find the number of sides of the polygon. Now, to know the number of diagonals inside the diagram, we have formula NC2 minus N is equal to 170, the total number of diagonals. So here it is N into N minus 1 divided by 2 minus N is equal to 170. So we get N into N minus 1 minus 2N is equal to 340. So N square minus 3N minus 340 is equal to 0. So on solving this, we will get N plus 17 into N minus 20 is equal to 0. So from this, we get N is equal to minus 17, N is equal to 20. So therefore, N is equal to 20 since N must be greater than 0. It cannot be negative. So therefore, for a convex polygon, the number of sides is 20. Next question. From a class of 9 boys and 7 girls, 12 students are to be chosen for a competition which include at least 6 boys and at least 4 girls. In how many ways can this be done if a particular boy is always chosen? So here, from 9 boys and 6 girls, 1 boy is already selected. So therefore, we don't need to select at least 6. So from 9 boy, if 1 boy is already selected, so we have only 8 boys. So from 8 boys, we need at least 5. And out of 7 girls, we need at least 4. And also from the 12 student, here minus 1, we need only 11 student. So let's write the combination. So out of 8 boys, we need 5 boys into, from 7, we need to choose 6 because 5 plus 8 becomes 11. Next, out of 8 boys, we need to choose 6 boys so that the 7 girls can have only 5 girls. Next, remaining is out of 8, we need to select 7 boys so that the remaining girls will be only 4. So this is the minimum selection of number of girls and this is the minimum selection of number of boys. So therefore, the total ways will be like this. So you will get 3 combinations of selection. So here we will get it as 56 into 7 plus 28 into 21 plus 8 into 35. So adding all these values, you will get the value as 1260. So this is the number of ways of selecting 9 boys, 7 girls from the 12 student, so that one boy is already selected. We need to select only 11 students from the remaining boys and 7 girls. So like this, they may ask you to arrange number of letters or number of people for 3 marks question. So 1 marks is very simple, either from circular or linear permutation. 2 marks question will be of the formula wise or circular permutation problems, and 3 marks will be from the combinations of letters, persons, objects, etc. We'll meet you in the next session with a new chapter. Until then, keep watching, keep learning, keep exploring. Thank you.